Yeah, yeah. Just I think all of you will be happy to see me. Not because I'm an expert or anything. It's the last talk, right? So, yeah. And how many of you like cricket here? Cricket. Yeah. So I have been given the job of a finisher here. So I'll try to be quick here. Yeah. Yeah. So yeah. So the topic for today, what I want to discuss is creating an AI-driven big data lake for security. How many SOCs in the room, people on the security side? Probably, yeah, we have some people. So, okay, let's proceed. Yeah. That's about, that's on me. I am just an, regular folk in the Elastic community. Whatever is written there, that's taken from ChatGPT. So, talking about myself, I just help a lot of organizations unleash the true potential of Elastic in all three areas, but this is a very interesting use case I've been working on, so wanted to share with you guys, right? So a little bit of who we are as GIOS Technology. We are a service-based company, right? An Elastic powerhouse helping a lot of organizations, as I said, deliver projects at scale for enterprises and public sector. So yeah, if you have more questions on what we do around the overall data space, we are actually left, right, and center of the data space. Elastic is one of the technologies, but yes, there are others. So if you want to discuss, I'm there. We can take it offline as well. So yeah, moving on with the actual use case. Yeah. So again, this project is being executed for one of the biggest telcos, via system integrator. The problem that they have as of date is they rely on their legacy SIEM solution, and what security folks are under constant pressure is firstly lack of budget. Yeah, so first they say we don't have budget, and they try maybe 3-4 different tools, and then they end up spending more than what they had thought they would, right? So the tools are in silos and the data is in silos, right? So it's very difficult to get an overall security posture of the organization from a single viewpoint, right? And that is something what every SOC dreams of, because as your organization size grows, that is the nature of your data feeds grow. The places in which your data feeds are, they are regulated, they are protected. They are not easy to be, we cannot just go and pull the data by writing a normal script. There are a lot of factors into play. I know the SOCs will be able to relate to that. On top of it, as I said, we are having in their legacy system multiple tools doing what Elastic can do alone. So they have got multiple tools to place as a data ingestion pipeline, right? When they are trying to collect data, we are talking about more than 100+ data feeds coming from their network devices, from their carrier data, from their network telemetry data, voice data, which is your analog data, which needs to be converted into vectors. And somebody here talked about vector database, right? So how do we generally featureize the voice and store it in a vector database and kind of pull that data into a SIEM solution? That is also a big challenge. And we have got on-prem data centers, the VMwares, yeah. So that's again one of the nightmares for the SOCs to really pull data from a variety of on-prem data center, custom-made servers as well as out-of-the-box servers. So those are there. At the same time, this organization is also on cloud and has got hybrid cloud infrastructure. So when I say hybrid, they are into not on-prem and on cloud, but multiple clouds they are using. They are on GCP, AWS. Hopefully they will go to Azure, because that's the only thing left. Yeah. So that's the complexity of data feeds we are talking about here. Now you can imagine to build a data pipeline, a single data pipeline to collect data from all those data feeds will be a challenge. And to collect the security logs and event and have one aggregation layer on top of it, and then to have a single SIEM layer on top of it, and then to be able to connect that SIEM layer to a SOAR layer. security orchestration and automated response layer at the top, from wherein you are trying to generate the cases and alerts and trying to send it to your destination systems is even more harder. They wanted a solution which one tool could do all of this, and luckily Elastic can do that, right? And the current technology which we are planning to replace, and it's again a POC which is being run, is the Hadoop ecosystem, right? So people who are already aware about Hadoop, it started as a big data lake with HDFS, and I'm not going against Hadoop here, but HDFS is slow as compared to Elasticsearch for obvious reasons. HDFS follows your batch processing of jobs, yeah, and there is a workflow scheduler which is there is a management layer, and massive parallel processing is not possible. Wherein Elasticsearch, and on top of it, Hadoop is predominantly a SQL, it relies on the SQL way of querying data and the SQL database to store data. Wherein Elasticsearch has the NoSQL way of storing data and the NoSQL compute and query engine, which makes searching on data really easy at scale and on huge volumes of data. So that was one of the biggest pain points which we are trying to elevate from an HDFS and the other Hadoop querying mechanism in place. On top of it, we would have what is called as the user tooling layer, right? So as an output layer, how do you visualize the data? We heard about Grafana and Kibana, right? The biggest advantage of Kibana is it is also a powerful visualization layer. So you don't need to really rely on a notebook or on scripts to generate dashboards and be able to provide an RBAC access to those security dashboards, because as security folks, the type of view your CISO or CTO would like to have about the security posture as compared to a security analyst will be way different. And how do you ensure that there is a compartmentalized view or an RBAC view? So that is one of the biggest challenges they had. So these were few of the challenges, well, not few, a lot of challenges, right? So which they tried to elevate using Elastic. So using Elastic, yes, of course, the first point, just to reiterate, was a log aggregator, what they are trying to create, a unified SIEM layer, something which can aggregate with an existing SOAR layer, and of course, then to implement your threat intelligence use cases, right, wherein Elastic, by the way, has rich set of threat intelligence integrations which we are already working on. MITRE framework, attack vector framework is one of it. There is Anomaly, and in the roadmap, I just heard there are more threat intelligence attack vectors coming in. So all the SIEM rules, and there are, by the way, I was amazed to have 1032 plus SIEM rules already there. So it's all about using the UI and clicking one button, and there you have, detecting complex threat hunting use cases which are correlated with threat intelligence arm. So that was again one of the major ask from a threat management perspective. Yeah. So moving forward, so I think I've defined the problem statement, but just to show it diagrammatically. So we have got a couple of data sources, as you can see. We've got network data, analog voice data, which is again getting stored into Elasticsearch's vector database. So we are vectorizing it, creating a dense vector embedding, and trying to store it in the Elasticsearch layer. Then we have got the service provider data and the customer data, the external data present. We have got the on-prem data centers, as I was saying, and then the public cloud, right, which currently are going to two log aggregation layers, right. So the first problem statement is, can we build something which is centralized? There are two SIEM layers which is currently integrated to the SOAR layer. In the SOAR layer, there was one more, if you can read the problem statement, as a part of in how do you respond to a threat, right? That is again a big question for the SOC. So there we have all heard throughout the day about Elastic's security AI assistant and use of large language model. So therein it is on the roadmap, I'll say. We haven't implemented it yet, but from threat hunting to threat discovery is what we plan to go to, trying to find the needle in the haystack, because if you get bombarded with hundreds or thousands of alerts, that's what a general day for a SOC looks like. You would like to know remove the false positives and see the threats which really matter for your organization, and to be also able to do what is called as a threat ranking and threat prioritization as part of your entity. So predominantly Elastic has 4 entities, right? The client, the IP, the host, and the geospatial data, right? So these would be the entities I would like to score with respect to the threat. So there is a correlation which needs to happen. Again, for the constraint of time, I'll not get deep into what we are doing, but again, I'm there, so please feel free to ask more on this. So then what is the Elastic solution, right? If you look at the last diagram, it was too complicated. We have joined the log aggregator layer. Now we just have an Elastic AI powered big data lake, you can call it, right? You have the Elastic solution up there, wherein for the big data, for the on-prem data centers, there is an Elastic Defend as a part of EDR and XDR solution, which does not only detect threat, but it prevents as well. So that is again we have done on the solutioning side of Elastic Security, which is getting integrated with the SOAR layer. Elastic has automated way of sending in alerts to I will say a lot of connectors. There are webhooks already present, so you could be sending it to your Jira, to your email address, or to whichever ITSM tool you are trying to use. Even Elastic, what we are planning to do is use Elastic's case management system to internally generate cases and assign it to SOC, again through an RBAC access control manner, so that not every threat is visible to every SOC. That's what we will be doing, and on top of it, to tail everything, as I said, we would have the AI-driven response, wherein currently we are exploring Gemini and GPT, a few other GPT models, but to make a privacy-first GenAI use case which is contextual and relevant, which can give them answers to particular threats that, hey, how does this affect my particular organization's revenue if there is, let's say, a ransomware attack on the network, right? So provided we get that revenue data, we can actually on the fly correlate the threat impact on the revenue and be able to generate a Kibana dashboard on the fly without having to go to Lens the old way, dragging and dropping and creating aggregations and custom formula. We can do it using the AI way of doing things. But yeah, so this is what I was trying to say. So if you look at the top diagram here, there are a couple of fault points which are marked in red, which we have tried to rectify. Yeah, currently data sources are there. Kafka is taking it, right? We have got HBase and LMDB for data enrichment, because in threat management use cases, you need to have what is called as threat enrichment. Yeah, if I know that there is a malicious IP which is trying to access my web server, I would probably want to know what is the latitude and longitude of that particular request. Maybe they are living in 2 different indices. How do we kind of create a join or an enrichment, right? And also there might be additional joins which is present in an external lookup table or a database. So currently that is being done all here and going to Apache Fume and then going to HDFS. And this is something, okay, we have a light, right? So this is what, if you see, it's quite complicated, right? As a developer or as an organization, I would not want so many things to be there. And you can believe me, I have worked on this project. So these are all different tools, by the way. Yeah, Apache different tools. Yeah, to name few, we have got Impala, Spark. These would be some of the tools. Uzi. So these would be some of the tools here. Now, what if I can kind of box all of this in just these 2 layers, right? So there is an immediate tools consolidation which I can have, saving a lot of cost, by the way. Now, HDFS is something which has been intrinsically created to handle petabytes of data, just not terabytes, right? So I would not go in here on a direct attack mode with HDFS, right? HDFS has still got its usage, and the customer is collecting data and storing there. Historical data is still there. So we can't just throw HDFS out. How do we ensure that Elasticsearch is able to talk with HDFS? There is an intrinsic connector, ES Hadoop, which we have used to basically let Elasticsearch talk with Hadoop jobs and vice versa. It's a bidirectional connector using which we could then do more, I will say, threat intel. From a threat intel perspective, we can get the intel of if something wrong has happened, let's say 5 months back, that I could get back in my entity scoring. Yeah. So this is what I'm been trying to do. Elasticsearch's data tiered storage is actually helping to wrap up this vast data store we are talking about. And again, from a daily ingestion perspective, I think it's close to 4 to 5 terabytes of data we are ingesting. So that's why the data tiered strategy is there. We are implementing the hot, warm, cold and frozen architecture. In frozen, we have the searchable snapshots to further reduce cost. And yeah, that's pretty much about it. These are some of the reference use cases. Why reference? Of course, I can't be really putting in the real use cases now. But you know, very quickly, you know, to query for indicator of compromises, you know, you would generally have the query based SIEM rule which is there. So in place, you have those custom SIEM rules. If you want to cross reference those IOCs with logs for incident investigation, you can use what is called as an EQL on top of what is called as a template UI. We have got a UI in Kibana where you can use EQL, or today we have a strong piped query language, ESQL, to actually do that correlation. You could pivot across different viewpoints in Kibana UI. Why? Because pivot hunting is very important. One data you are viewing in one context, but you want to view it in other context as well. How do you pivot across seamlessly? You can do that as well. You just don't want fixed workloads or fixed queries to run against your threats. You would want parameterized query. So in Elastic, there is something called as search templates. And within search templates, as Ashish was mentioning, you can use painless scripts, which you know, we have to create SIEM rules. Yeah. So within search templates, we are creating scripts to sort of customize our logic of hunting a threat. What if those are not present in 1036 rules, which is still possible. Finally, those are quite obvious, you know, the alerts based on the ML, the anomaly detection jobs which would run, wherein we don't need to break our heads on creating a lot of ML routines and run books on Jupyter or somewhere and trying to run it. So yeah, that's all we are trying to do. That's about it. Yeah, I'll say, and I'm right on time. So yeah, thank you very much. Yeah.
Yeah, so this entire solution, the Elastic Stack, is it deployed on-prem or cloud? Because I saw a lot of heterogeneous systems involved, right? Is it on-prem or?
On-prem.
On-prem. Now, if it is on-prem, how do you ingest all the data that is there in cloud? How do you bring it to on-prem?
So there is no one simple answer to that, right? As we would have an agent-based solution, right? So we have got, luckily there is still an integration to actually bring in your entire Azure ecosystem services or AWS services. You know, for example, if you want to know the what is called as a cloud security posture management, CSPM. So you have got those integrations already available. We are using, and we can't be using some of them are custom. So we again, you know, we have written some of the Python scripts to be pulling in data using you know, type of file beat, you can say. Yeah, it's not a beat per se, but we have written a script to pull data. Predominantly it's agent and integrations.
And let's say that you have instances within the cloud environment, right? How do you get logs from those instances back to your Elastic solution?
So as in the public cloud, right? The public cloud. Yeah, so as I said, right, we would have an agent being installed there. So one agent would be installed in your entire cloud instance, the entire cloud account, right? And whatever services you want to pull data from, you would then be installing the required integrations in Elasticsearch's side and using what is called as a fleet server UI, sorry, a fleet server. On a fleet server, you host that agent, right? And you have a policy called as agent policy where you can handle the integrations as and when your scale grows. So you just have one agent and you just keep plugging in the data sources. That's going to send data to Elasticsearch.
Okay, thanks.
In your use case, you are mentioning about 3 problem statements. I was agreed for the Elastic to search and or to use for 2 of the statements. The first statement, you are mainly talking about threat detection, threat management. Already public cloud is providing by default threat detection, if you are having any medium or critical, you are getting already alerts. Why you can't leverage that?
So so going back to the very first problem statement, right? Those clouds are again interacting with the on-prem system. So the way we want to have a solution to provide an unified view of security across on-prem and cloud, I will say ecosystem, not infrastructure, ecosystem, wherein there is a correlation which is happening. That correlation can be only found out if there is one single data store having data from all the sources, right? So you get it, right? So
yeah, for example, okay, that may help for the application perspective. Maybe you have hosted some few of the infrastructure in Google Cloud. You may be some DDoS attacks or threat detection. Are you taking care of those also in Elasticsearch, or how about that?
So we are still in the process of building the rules, I will say, but yes, if it is already available in Elastic, we would rely on that as a single source of truth. Rather, see, the end of the day, you would want to have one technology, one solution in place. So we would, stick with Elastic as the de facto standard. Yeah.
Thank you.
Thank you.
I think we have anomaly detection for DDoS.
Already SIEM rule is there for DDoS.
Yeah, Raj, thanks for your insight. I just have one question. So you were talking about a little bit, you touched about SOAR automation, right? SOAR capabilities. So I understand Elastic Agent can do the automation part for the place where you can deploy the agents. So what about the network related logs where you're collecting, and even let's say cloud, AWS, or you're talking about GCP. So we are using CSPM to get the insights. So in that case, what are the automation you can able to achieve? So I believe our Elastic Agent can't be used on that. So
yeah, so yeah, just to make this thing clear, we don't have one stop solution to collect data. The problem is the data sources are so many spread across. So in fact, just to I can't name the exact sources, but we have beats. We have got Logstash, we have got agent, to give you a flavor, right? So wherever the files need to go in a syslog server sort of a thing, we have got FileBeats doing it. If not FileBeat, we have got a Python script doing
yes.
that, right? Wherever there is an additional need of processing, that is a data cleansing or an ETL process which is required, which is heavy on processing, that we are trying to avoid in ingest node pipeline and doing it in Logstash through Logstash processes.
Okay.
Yeah, enrichment part. I think there was one use case on log correlation and log enrichment, right, by one of the speakers. You can still do what we are doing it within Elasticsearch, but decoupling that using an ingest node pipeline within an ingest node in the cluster, where we have what is called as an enrich processor. Using enrich processor, you can actually create have a table or an index which will act as your source of truth, and you can enrich either one index or a group of indices using that. So we are actually, and that is, I will say from my experience, it's faster and more easier to do than doing it in Logstash filters.
Okay.
So that's how you. So to answer your question, we have multiple Elastic.
What about automation? For example, remediation. You detected the threats, and let's say in network or let's say in cloud. So what you are doing for remediation part, because Elastic Agent can't be deployed on these 2 places. So how we can handle? You have any insight on that?
So remediation, as in where Elastic Agent is failing, is it?
Where we can't deploy it.
Where we can't deploy
yeah.
it. Yeah. So that's what we said, right? We have a script sending it to a temporary server.
Okay.
Through, it can act as a syslog server, and we would have file beats, and it's very easy. You just point the file beat harvester to the start point. It's going to collect. The point is there is additional requirement of the script to send it to a temporary server. That's a challenge. If there are no ports which are blocked, FileBeat can directly access it. You can try it, but in our use case, the problem was it's a highly regulated environment, so we can't have FileBeat accessing it. We have to put it in a temporary server, and from that FileBeat is going to pull it.
Okay.
Yeah.
Thank you.
Thank you.